In this lemma, we'll find two square numbers whose sum is not square. Let a and b be similar plane numbers so that ab is square, and let both be even or odd so that their difference is even and may be split evenly in half. Using lemma 29a, ab plus a minus b halves squared is equal to a plus b halves squared, so that ab plus a minus b halves minus 1 squared is less than a plus b halves squared. We'll show that ab plus a minus b halves minus 1 squared is not a square. By way of contradiction, assume it is square. It will either be equal to, or less than, or greater than a plus b halves minus 1 squared. Let's first address this greater than case. Euclid dismisses this case backhandedly, so I'll show you what he means. Start with the line A and designate a portion of it to be B. So we have the two lengths a minus b and b. Cut the a minus b part in half, draw the rectangle AB, and on top of it draw the square of side length a minus b halves. Let's now shift things around to make a square of side length b plus a minus b halves. We are deficient by a rectangle of side length b and a minus b halves, which we conveniently have, so let's slide it into place. We just proved ab plus a minus b halves squared is equal to b plus a minus b halves squared, the first lemma of this proposition. We'll now give 2 of the square so that we can compare them. The left one is ab plus a minus b halves squared, and the right one is b plus a minus b halves squared. In this lemma, we restrict the actual values of these square numbers to be whole numbers. Now, take the square of side length a minus b halves and bring it down to the next lowest square number. This is done by removing a row and then a column. This square is now a minus b halves minus 1 squared. Do the same to the square of side length b plus a minus b halves squared to get b plus a minus b halves minus 1 squared. Now let's take the left figure and see if we can make a square of side length b plus a minus b halves minus 1. We'll bump this stuff to the left, and it turns out we can't, which shows the figure on the left is bigger than the figure on the right. Now here's the caveat. Euclid is only concerned with whole number squares. To make the figure on the left a square bigger than the square on the right, we would have to take the left over bits and split them to lengths less than 1, and our square would not be a whole number, so Euclid considers that ab plus a minus b halves minus 1 squared not to be greater than a plus b halves minus 1 squared. This visual proof also covers the cases of equality and less than, but let's see how Euclid does it. First, let's assume ab plus a minus b halves minus 1 squared is equal to a plus b halves minus 1 squared. Now a minus 2 times b plus a minus b halves minus 1 squared is equal to a plus b halves minus 1 squared. So a minus 2 times b plus a minus b halves minus 1 squared is equal to ab plus a minus b halves minus 1 squared. So a minus 2 times b is equal to ab, which is a contradiction. So ab plus a minus b halves minus 1 squared is not equal to a plus b halves minus 1 squared. Let's now assume ab plus a minus b halves minus 1 squared is less than a plus b halves minus 1 squared. Or that ab plus a minus b halves minus 1 squared is equal to the next smaller square, a plus b halves minus 2 squared. Now a minus 4 times b plus a plus b halves minus 2 minus b squared is equal to a plus b halves minus 2 squared, so a minus 4b plus a plus b halves minus 2 minus b squared is equal to ab plus a minus b halves minus 1 squared. Or minus 4b plus a minus b halves minus 2 squared is equal to a minus b halves minus 1 squared. Or minus 4b plus a minus b halves minus 1 squared plus 1 minus 2 times a minus b halves minus 1 is equal to a minus b halves minus 1 squared, or minus 4b plus 1 minus a minus b halves minus 1 is equal to 0, or minus 4b plus 1 minus a minus b plus 2 is equal to 0, or minus 3b plus 3 minus a is equal to 0, or 3 is equal to a plus 3b, which is a contradiction because the smallest number b can be as 1, and a plus 3 is greater than 3, so overall ab plus a minus b halves minus 1 squared is not square.